Hi guys, and welcome to another edition of Algebra Underwater. Apologize for the sound quality. This is as best as it's going to get. But today what we're going to be doing is we're going to be moving from graphing quadratics from the vertex form, which we've done the last couple of lessons, using the formula f of x equals a times the quantity of x minus h squared plus k, to something called the standard form. This is just another type of way that we can graph quadratics, or ways that we can represent quadratics, similar to that of when we were learning linear functions. When we were learning linear functions, we learned lots of different ways to represent a linear function. That's not it. Here it is. Slope-intercept form, point-slope form, standard form, right? This is just another form of a quadratic. If you do not have this yet, please make sure you get a copy of it, and then pause the video, get the copy, come back, and we'll begin. Right? First thing I'm going to start with is, what is the standard form of a quadratic? And the standard form of a quadratic is f of x equals a x squared plus bx plus c. Okay? And you can see we have three different examples on this note taker that are in this standard form. We're going to be able to graph using the standard form by finding three different characteristics, or three different components of it. The first thing is the axis of symmetry. I'll show you how to find that. That's where the quadratic flips, right? It's where it mirrors itself, where the vertex, it hits the vertex and then either comes back down, or hits the vertex and comes back up. That's your axis of symmetry. The vertex is either that lowest or highest point, and then the y-intercept is the same as when we were doing slope-intercept form with our linear equations. It's where it hits that y-axis. I'll go through how to find each of these, and then I'll use those to then graph a quadratic on the coordinate plane for you. We'll go over a couple of examples. I'll give you time to do one of them on your own, and then we're going to look at what does this look like with a word problem. And that's kind of where we're going with this lesson. So without further ado, we are going to go ahead and look at the equation f of x minus 2x squared plus 8x minus 1. This is in standard form. We're going to go ahead and graph that. The first thing we want to do is we want to find the axis of symmetry. And in order to find that axis of symmetry, that point where the equation mirrors itself, we're going to use a very specific equation that you're going to have to remember, but it's pretty simple. This equation is x equals negative b over 2a. And we're going to use the quadratic to fill in the variables b and a to solve for that axis of symmetry. When I look at this quadratic, the b, if I look up here, is always going to be the coefficient of x, that's 8, and the a is going to be the coefficient of x squared, or 2, giving me 8 over 2 times 2, negative. When I simplify that, that's 8 divided by 4, or negative 2, meaning that the axis of symmetry for this particular graph is x equals negative 2. We might as well graph that, because that's going to be the first thing that we want to do when we're graphing a quadratic. X is negative 2 here on this coordinate plane. I'm going to just use my straight edge to draw that axis of symmetry, knowing that my vertex is going to be somewhere along that line. Now, knowing that is going to help us find the vertex. We already know one thing about the vertex, which is that the x value is negative 2. So we can use that to figure out what the y value is, or what the f of x value is. And we can do that by just inputting negative 2 into x in this quadratic function. So when I do that, I get f of negative 2, because that's what we're inputting for x, equals 2 times negative 2 squared plus 8 times negative 2 minus 1. Now, when I'm simplifying this, don't forget, order of operations says that we need to do our exponents before we do multiplication or addition. So I always want to multiply this first, and then, sorry, there's something on my screen, and then solve. So negative 2 squared is 4. So this gives me 2 times 4 plus 8 times negative 2 is negative 16 or minus 16 minus 1. 8 minus 16, negative 8 minus 1 gives me negative 9. So I know that my y value in my vertex is going to be negative 9, giving me the coordinate negative 2, negative 9 as my vertex. Negative 2 coming from up here where we know x is negative 2, and negative 9 down here. So I'm going to just go ahead and plot that on my graph, knowing that this is the vertex. That's where it's going to switch over. And then last but not least, I'm going to find my y-intercept. Now the y-intercept is really easy. It's always going to be your c value. So in this case, my c value is negative 1. So, and I can even write this so that I know when I come back, it's going to be that c value. So our y-intercept is negative 1. So that means that I can plot a second point on this parabola. Once I plot that second point, I have enough to graph it. The reason why is I can just mirror this second point over here. I now have 3 points that if I were to draw a nice little U shape, there's my parabola. Okay, just to recap what we did, we found that axis of symmetry. We used that x value from that axis of symmetry to plug into the function to find the y value. That gave us our vertex. And then last but not least, we used the y-intercept to graph it. Okay? So that is how we graph a parabola using the standard form. I'll do one more, and then I'm not going to do that last one on video. I'll have you pause it and then see if you can't figure out how to do it on your own. I will show you the solution afterwards, though. Okay, so number 2, we're going to do the same thing. We'll find the axis of symmetry using the axis of symmetry formula. I'm actually going to, I think, highlight this so it's something that pops out to me. Definitely want to know that, so we use it because we're going to use it over and over again. So if my axis of symmetry formula is x equals negative b over 2a, the first thing I need to do is identify what b and a are. B in this case is 2, a is negative 0.5 or negative 5/10. So I'm going to just plug them in. Negative b, or 2, over 2 times negative 5/10. Okay, when I simplify that, I'm just going to simplify the bottom first so we can really look and see what this is saying. 2 times negative 5/10 is negative 1. A negative times a negative makes us a positive 2. So our axis of symmetry in this situation is x equals 2. So let's go ahead and graph that, because we know that this is going to be where my vertex is going to lie. The vertex is the next thing that we're going to find, and we're going to use that x equals 2 to plug into our function to find the output value. So this gives us negative 0.5 times, instead of x, I'm plugging in 2 squared plus 2 times 2 plus 3. Again, we'll make sure that we use the exponent or order of operation, which says do exponents first. 0.5 times 4 plus, just simplify this, 4 plus 3, which gives me negative 2 plus 4 is 2 plus 3 is 5. So our vertex in this equation is going to be 2, 5. I'm going to graph it, 2, 5. And then last but not least, I have to find that c value. My y-intercept is 3. I'm going to graph that. I'm going to mirror it on the other side, and then I have my parabola that I can sketch. Notice this parabola faces down, while this one opens upward. That has to do with that first a value. 1 is negative. If it's negative, it opens down. If it's positive, it opens up. Now what I'm going to have you guys do is pause for a second, not for a second, I'm going to have you pause and then try to complete the third question. When you are finished completing it, go ahead and unpause and I will have that one completed so you can check your work. So you had a chance to practice question number 3 on your own. This is what the axis of symmetry is, where your vertex is and your y-intercept and how you graph it. Now, if you want to get more accurate, which I do recommend you do, and I wish I would have done this earlier in this video, you could find another point on your parabola to see where it goes, because I was looking at this one, I was like, I could probably find another point. And the way that I can do that is I can just find another x value and graph it. So for instance, I might want to find the x value of like -1 here. Which means where is my parabola crossing when I get to this -1? And the way I do that is just evaluating this with -1. So 0.5 times -1 squared plus 2 times -1 plus 3. So that gives me negative 0.5 times 1, or just negative 0.5, minus 2 plus 3, which is 1/2, 0.5. So the point that I could plot is -1, 0.5. And notice my original graph wasn't exactly where it should have been. Now, when I want to plot the second point on the other side, all I have to do is just say, all right, here is 1, 2, 3 away from the vertex, the vertex or the axis of symmetry. If I plot it 1, 2, 3 away, and you can see I was a little bit off. So my graph is going to be more accurate if I have that second set of points. So I apologize for not doing that earlier. I just recognize that with the 3 points, I was estimating where my graph would be. For the first one up here, I probably would choose an x value of like -3 here to see where it hit on this line. My sketch is probably a little bit off. So I challenge you to go back and figure out what would be that second set of coordinates that you can use to be more accurate with your quadratic sketch. Now we're going to finish with just a word problem so that you can see what this looks like, and then I'm going to have you do the last one on your own. So we have this word problem. Mia tosses a ball to her dog. The function it gives us in vertex form is f of x is -0.5 times the quantity of x minus 2 squared plus 8. Okay, the vertex form tells us a lot about the situation. You guys can go ahead and figure that out. The first thing it's going to tell us is it's going to tell us what the vertex is. And the vertex in this particular situation has to do with the h and the k, 2 and 8. So I see that when the ball is 2 feet away from Mia, it is 8 feet high in the air. Okay. It also tells me that it is downward facing, and that's because the a value is negative. You can also say that it is wider than the parent function because this value is less, the absolute value of a is less than 1. But other than that, that's pretty much what the vertex form tells me. I could graph it 100%. I could plug in a value for x, evaluate for x, find some points, and then solve it. But what we can also do is we can rewrite this in standard form. And the way that we're going to rewrite it in standard form is by doing some foiling. So I'm going to rewrite it down here in the vertex form, -0.5 times x minus 2 squared plus 8. And then I'm going to simplify. Okay, the way that I simplify first, a lot of people might think, oh, I should just distribute this negative. No, you cannot distribute that negative because this is not a multiplication problem. So what you actually have to do in this case is multiply x minus 2 by itself. This is what x minus 2 squared is. Right? We can use the strategies we learned last module to simplify this. We can FOIL it, we can do lots of different things. What I'm going to do is I'm just going to use my method, one of my special cases. So this ends up being x squared minus 4x plus 4. Now I'm going to input that